But we're hiring all the time. We're striving towards that infinite number of employees that will allow us to make that actually 100% true. Okay, what's a callback? The concept, which by now is like old and totally digested, but used to be somewhat perturbing, is when some library or framework is going to call your functions. The traditional concept of a library, born in the 50s and the 60s, was, hey, here's a bunch of functions, go ahead and call them to do cool stuff for you. In the callback, things are reversed. You don't call them, they call you. Why would that be helpful? The principle has been named by Richard Sweet. Indeed, it is a sweet pun, the Hollywood principle. You know, you go to Hollywood, I don't know if you bother going to Southern California, but to like try out for some big part, like are there on the stage doing it, they, thank you, don't call us, we'll call you. That's actually not a particularly promising introduction in that concept. But this shows essentially that the date of this, 1985, for some of you is like, wow, I'm older than the concept of callbacks. For some of me, it was like, cool, I was already working then. I was recently mentioned, although a very young grandfather, I am a grandfather now. So what is the purpose of being called back by libraries or framework? I classify that into two possible motivations, which we'll both explore. One is get better flexibility by customizing some aspects of how the framework is working for you. Instead of having to tell the framework this is how you work at the very start with some initialization call, the framework calls back to you whenever it needs to know, what do I do here? Your callback function will tell it. And this is one important class for which I would say there are very few alternatives. This is simply the fact that instead of giving the parameters for all at the start, you give them like every time, so it can change depending on situation and so on. That's nonpareil flexibility. And then there's all the event-driven architecture. Event-driven architecture was actually born in the world where events outside of the system actually occur and are important to react to. Probably started with graphical user interfaces, so around the early 80s when GUIs were coming of age, or late 70s in the research world. And then somebody noticed that, hey, networks work exactly that way. Stuff is happening outside. It's not a human being, it's some other node in the network, but things are happening and need to be responded to. And the concept, for people whose minds are sufficiently warped, which I hope covers most of us, it proved to be such a useful concept that artificial events, just to be able to structure your program, items for which there are many alternatives. I'm just trying to show why would somebody want to program like that in a couple of situations. What the implementation of a callback, no matter what the purpose of the callback is, I spent some time discussing why would you want to do that. How would you want to do that? Well, you just need to have a language with callable objects, which, with the possible exception of Java, I believe applies to every modern language. Somebody would say not having first-class callables means Java is not a modern language. It's a relic of the deep past. Every language lets you pass around, even C lets you pass around a function, for Christ's sake. It's not, doesn't take, and C was written by a guy who's older than me now, so it's really not the newest languages. Anyway, you hand that callable object over to some part of the framework. Whoever you're handing it off to, I'd better stash it somewhere, somewhere might be very transient. Maybe it just stays a local variable if the scope in which the callback needs to happen is limited to the execution of a single function, or else it will put it in a container, set it as an attribute. You don't really care from the outside how does the framework preserve your callable object. Just make sure that it does. And then, if and when appropriate, at some point in the future, this callable object of yours gets called back, because you originally did some kind of call to hand over the callable, and now you get the call back. Either because it needs to know something to customize the operation, that's the first kind of motivation, or appropriate events occur, like state changes, user actions, I/O events, network, timeout, system stuff. The system is about to catch on fire. You better do something about it. Or events can be made up for structuring control flow appropriately, as we'll see. Now, customization is not necessarily limited to tailors anymore. We also want to do it in software system. And let's take a really simple example. I have a list of stuff, things, in this case probably strings. I want to sort them, but not just sort them any which way, sort them in a customized way. For example, I'd really like to sort them in a case-insensitive way. How do I do that? Well, let's read the things backward. The original approach to doing this, which I kind of wrote up, I discovered, I didn't invent it. It was already being used in important code and called the DSU for decorate, sort, and decorate, proceeds like that. I make an auxiliary list which includes the objects of the list, their indices, and some kind of key function applied to them, which comes first, and then I can use a natural sort, the lexicographical sort of Python. Things with different keys are sorted in order of key. If the keys are equal, then the indices are going to be different. Note that the objects themselves never end up being compared. That's actually an important detail of the semantics of DSU. And then I have to undecorate, that is, extract the objects back into my list. This is for an in-place sort of my list. So this is and was a great idea, but it really kind of cumbersome to have to keep coding it. So Raymond Hettinger, who you had the pleasure to listening to last year, said, hey, I'm coding this sort of thing all the time. It's getting boring. Why don't I put it in the interiors of the sort method? If, after all, the only thing that changes between one specialized sorting and another is what function do I call to get the sorting key out of the objects. So let me just pass the sorting key. In this case, I'm using the toUpper method of object class type str because they'd better all be strings. It wouldn't work if I had some Unicode things there, and therein lies the tail. Well, but as long as they're all byte strings in Python 2 something, this thing, and by doing all of these internals internally where they should be done, I strongly recommend to any Pythonista with decent C background to study the Python C internals. They're extremely interesting. But essentially it does all of this internally, and so it can also be much faster, as well as abstracting away all the details of the implementation. It does guarantee, for example, that the objects themselves will never be compared directly. So you could apply to, with an appropriate key, to say a list of complex numbers. You can never compare two complex numbers for greater than, less than. That would raise an exception. But with DSU, use abs, for example, so they, the objects are sorted in order of absolute value. you're going to be absolutely fine. You also gain an advantage of abstraction. You're working at a higher level of abstraction when you're using the callback customization than you are when you boringly code it out. As usual, more often than not in Python, the higher abstraction you think and work at, the faster you get. That's exactly the reverse of what you get with most languages, which Alexander Stepanov called the abstraction penalty. How much does it cost me? How much does it slow me down to use abstraction? In Python, typically, the abstraction penalty is an abstraction premium. You actually get rewarded for being more concise, higher level, and more abstract. And this DSU example is a perfect one. Now, I did kind of mention in passing a little problem. If I was doing the comparison directly instead of passing on the key function, I would have A and B, and I would say A to upper open close less than B to upper open close. I would be calling the method to upper on the objects A and B. This way, I'm not really calling the method on the objects. I need to call some callable on each object. So I'd better have a callable that can be applied to each object. So I'm kind of breaking the abstraction layer of object-oriented programming, which sometimes okay. Like if I know that all the objects are of class str, then passing a method extracted from the class str will be fine and not too badly break the abstraction of object-oriented programming. But sometimes you really need to be getting properties or calling method in the object-oriented way. How do you do that then? Well, you typically start by import operator, a standard library module, to which Raymond Hettinger, you may already be familiar with the name, added a couple of useful tweaks. Operator has been around forever, but it typically abstracts into callable such things as addition, multiplication, you know, operators. Raymond added utter getter, and I don't think this was him, but somebody in the same vein added method caller. So utter getter, you give it the name of an attribute, and it gives you back a caller, so it dynamically constructs and returns a caller that will directly call that, extract that property or attribute from the objects. So if your objects carry an attribute k, which is the key along which you want them to be sorted, this is how you do it. I already mentioned the possibility of extracting from the class to which all the objects must belong some method without arguments. That may be a bit restrictive. Maybe you also want to pass some arguments. Well, then you can use the method caller method. Note that this, in some environments, is known as higher order programming. So take it as a compliment. When you're calling a function that returns another function, in some languages that's called higher order programming. In Python, it's, I believe, just as easy as 2 plus 2. So method caller takes the method name and arbitrary set of positional and keyword arguments, and will extract this method and call it with this argument from each object to obtain the sorting key. Of course, I usually get at this point an objection, but I could have written a lambda to do that. Well, you could have, but you don't have to, and when you can avoid lambda, you're usually going to be much happier. Don't believe me? Time this. Use the Python -m time it approach and see how many microsecond or nanosecond does it take to do this versus doing that. And you'll find out that avoiding lambda, programming at a higher level of abstraction, rewards you with better performance. Now, to see if anybody was following on, what's common to all these approaches and this one that I couldn't just have done? Wait a second. C approach is different. I remember doing sort in C. I also pass in a function, but I pass in a function that gets called with 2 arguments and must return -1, 0, or +1, depending if they're to be considered equal, or 1 is less, 1 is more. What does this key extraction concept buy me? I'm more used to passing in the comparator function. Unfortunately, sort, given that Python was obviously heavily inspired by C at many levels, they're very close languages philosophically, also has a CMP optional argument that lets you pass a callable that will perform the comparison, just like in C. Why would you want to use a key approach versus the C-like approach of passing in the comparator? The answer can be a single uppercase letter.
Sometimes calculating the key is expensive. Calculating the key could be expensive.
It could, and therefore, what's a single uppercase letter that explains why you want to do it with key? Big O! I hope we have a piece of shrug for this guy who got it exactly. The number of comparison you're doing is going to be big O n log n. The number of comparison you're doing grows more than linearly, not that much more. Log n is a well-behaved function, but still. In this way, all you need to do is big O of n, is actually exactly n. You need to extract the keys once per object, so n times for n objects. So of course you get faster, especially if, as the other gentleman said, the key is costly to extract. This system can, in this case, very explicitly cache the key computation for you, but the key equal argument does it just the same. So thank you for the cooperation and the first order success. Also, key equal is not only for sorting, it's such a handy thing that it was generalized to max, min, almost everywhere you'd really want to use key transformation instead of, if you're really deep into OO, the customization, not just for sorting, but in the more general case, is done via callback in the somewhat rigid design pattern known as template method. The template method design pattern has been described somewhere, perhaps with a bit of an excessive enthusiasm, as the spirit of object orientation. I have a long presentation at this URL. I suggest you get the PDF via the URL that's on the first and last page, and as opposed to trying to write this one down, and then follow this. At slide 49 and following, because it's a presentation on all sort of classic design patterns as they occur and get applied to Python. It's somewhat rigid, and I also suggest all sort of more flexible alternatives, but the general point is that in some abstract class, parent class, you call self some hook method, and then the child classes implement the hook method. This isn't obvious, but it's always also a case of callback. It's not obvious because you're not like handing over explicitly the callable, but you're creating the callable by overriding the sum hook method in the concrete child class, and that is how the objects find the organizing method finds the hook method to call. Let's give another example of customization, which unfortunately isn't surviving in the Python standard library, but I still think it was a very nice and clean design. scheduling. I want to be able to schedule a series of events. The events I'm scheduling are, of course, going to be, in concrete, calls to my method. So there's also this, like normal, semantic event-driven level of callbacks. But forget that for a moment. The point is I want this to be called in 5 minutes. I want that to be called at exactly 9 p.m., and so on and so forth. How, if you think about it, how you're going to implement this? Well, you're going to keep a queue of things, and you will need 2 core functionalities. Some way to tell what time is it right now, and some time to say sleep until the time of the first scheduled event to occur. So you don't just spin around in a tight loop asking, are we there yet? Are we there yet? Are we there yet? And looking forward, I had my experience with my children, like every parent. I'm looking forward to having it again once my now 2-month-old grandson gets old enough to speak and be driven around. One way you could consider would be, well, the old-fashioned but still present time module offers time.time to tell me what time it is, and time.sleep to wait and for a certain duration of time. So I could have a scheduler object accept the module as an argument, modular objects like any other thing, and just call its time and sleep functions or methods. There isn't really any deep difference in terms of the syntax that Sched will be using. If you're focused more on functional programming than object-oriented programming, you end up with the architecture that was in the Python standard library. You pass separately the time function and the time-sleep function, so that they normally will have to go hand in hand. How you tell what time it is and how do you wait until or for a certain time had better be synchronized with each other, which is the argument for having them as method of a single object. On the other hand, advantages of passing them separately, you don't need them to be named time and sleep, for example. You can name them anything that's clear in your context, because the scheduler would receive them as callable objects. It doesn't care what they're called, it just calls them. It holds them internally. And another factor, you could also supply default for them. If you want to allow your user to customize you by callback, but not require them to do so, you could have the 2 function default to time.time and time.sleep unless explicitly passed with other values, which in general, convenience is not a bad thing. In practice, the original designers of the scheduler module decided to not have any default, so the user must, is explicitly made aware of the need to specify those. They're both valid choices in different contexts. I'm not going to pronounce on it. The object-oriented evolution of this is the dependency injection design pattern. I've already given you the URL to my general design pattern coverage. There's also, unfortunately, I should have put the URL here, but I think if you look for Alex Martelli dependency injection, you'll find my talk specifically on an in-deep dive on the dependency injection, how is it used in Python and why. It also, in a sense, boils down more often than not to callbacks. Although you could give non-callable objects, but mostly you will be given callables such as factories. So this is the part where I cover callbacks for customization. I hope it's obvious why they're more flexible, as I claimed. In some cases, you couldn't possibly just specify things once and for all, not with callable, but with values. Like here, you can say, okay, and the time it is 5 p.m. Okay, and how do I, that was the time you called me, and now it's past some time. How do I know what time is it now? I obviously, that is progressing continuously, and also what I might need, not know some parameter, but perform some action, like sleeping. I need to do something in order to sleep, that is wait for the next appropriate time. But also, even if all they is doing is just returning a value, it can return a different value at different time. Like in the sorting customization case, it's obviously not just going to return 23. That wouldn't produce a very useful sorting. If every object has a key of 23, you end up not sorting anything. The object that, the value that gets produced must depend on the object, so the flexibility of the callback for customization is absolutely crucial. Any question on this part? I think, or we can wait and have all the questions at the end, perhaps. But I'm now going to move to events, which are a rather distinct thingy for the second part. So, okay. Events. Does anybody recognize this kind of diagram? Okay. So, as I keep saying, but the repetition is not because I'm becoming old and doddering by having a grandson. I was old and doddering before then. But it's an important principle, a design pattern in writing articles or giving talks. Tell them what you will tell them, then tell them what you've told them. That's the way people actually retain information better. So I'm trying to apply that by this pattern. There are actual events, stuff that is indeed happening somewhere outside or within the purview of the system. User do stuff. They move mouses, anyway. They click buttons, they so on and so forth, and each of these is an external occurrence, event in this sense, that you want your user interface to be able to respond for. Then there's stuff more inside the system, like the observer-observable design pattern. One object is doing stuff. Another object wants to respond to some of the stuff the former object is doing. So the observable is the object doing stuff, and the observer is the one who needs to respond. And then there's I/O. I/O is often modeled as in do the command and just wait until it's done. But depending on who's responding, the wait might be very long, and you don't necessarily want to program it in this synchronous way. You normally do, like you're reading a file, you're saying x equal myfile.read open close. That may, I don't know, may wait a few milliseconds, who cares, is your usual attitude. But depending on what you're programming and depending what that file-like object is, the wait might be very long, so you might want to actually be reading a line at a time and not wait for each line to arrive, but do something until it's done, do something else until it's done. Networks are particularly prone to that because delays can often be orders of magnitude more than for local stuff local to your system. And then there are system events, like the system is getting turned off, for example. The program is about to terminate in a slightly smaller scale, but not conceptually different from somebody operating the on-off switch on the whole system. You may want to be able to respond to that. For example, oh, it's about to terminate, let me save some information so I can restart properly next time. And then, when people have had become used enough to events as a way of thinking, because they were programming a lot of GUIs and networks and things, they started making up events to be able to use those structures in where the events are not necessarily real. like event-driven parsing, we'll mention that. The scheduled callbacks and the concurrent callbacks is slightly different, and all sort of timing and debugging, which we want to really be able to get into that much. But for example, I did mention timeit in passing. Python's -m timeit starts the timeit module. The timeit module needs something, some way to set up the situation and something to call repeatedly, so it can call it 1,000 times and tell you how long the average time took. Those are conceptually callbacks, although what you usually pass as strings, of Python code which it parses. And the same could apply to PDB, but let's not, I'm not really going in depth in that part. Let's start at the beginning, where actually the practice of event-driven programming did, if not really start, definitely took root heavily. The early graphical user interface frameworks, Python used to come with tkinter, which is a peculiar GUI framework, but it works like all others with a lot of callbacks. Some events are pretty macroscopic, like user clicks a button. Okay, user clicks a button. What happens when the user clicks a button? The typical approach is something very simple. A command that is some sort of argumentless function gets called. So it's a callback responding to the macro event. And then tkinter goes in depth, allowing you to set bindings between what you could call classes of events and callbacks. For example, enter, leave, that's a mouse has entered a widget, the mouse has left a widget, some key has been pressed, or you could be more specific, like a specific key press only, and so on. And upon that event, the handler gets called with an event argument. While the command here is just called without arguments, in this case, the callable takes an argument which describes the event in details, which attributes which widget, which X and Y position for the mouse, and so on, what type of event, so that a single callable, by analyzing the event object, can deal with slightly different situation. You don't have to bind to a specific widget, but you can bind to a whole class, to all widgets, to a certain root window, and so on. So it's a very flexible way of binding stuff that can happen, the event, or classes of events, on one or a group of widgets, to a callable that will be required to deal with that. This is a specific tkinter system, and there's plenty of other excellent ones, but in practice, at a conceptual level, they all work very similarly. Some will not have this kind of flexibility. You may have to write a big block of code to bind a certain handler instead of matching by class, by root window, and so on. But that's, in a sense, a minor implementation detail compared with the conceptual thing, that things happen, a handler gets called, the handler is responsible for doing stuff in response to the thing that happened, which it either knows implicitly when it's called without argument, or gets as an argument so it can analyze exactly what happened in detail. Are there alternatives to this? Some, to some extent. You can, for example, it's described as not needing a handler, but in certain frameworks, such as Qt, you can connect directly a source of signals, which I would call events, to a sink of signals. And that could operate without you having explicitly to code what's going on, but that's just using a handler implicit in the system. For example, if somebody clicks here, close that window. You may not have written the code calling this window.close, but that's only because the system supplies it for you. So it's not really a deep conceptual difference, okay? Now this, if you think of the event happening on the widget is because actually the user is doing something. The system completely external to your stuff. But you could think it as, okay, the widget has done something, the status has changed. That's a slightly different conceptualization of the same thing. The mouse gets in. Well, duh, the user has moved the mouse and the pointer has gotten within this particular rectangle. Yes, but I could see it as the state of the widget has changed from not having the mouse in to now having the mouse in. And when you conceive of things that happen as happening to certain particular objects, you're almost arrived to the observer design pattern. Again, there's that big URL where I cover all sort of design pattern. Here I'm just seeing it as a specialized form of callbacks because it is. You can add observers, note the plural. That's a typical, often a difference with the GUI paradigm. Instead of saying, well, this event has happened, so here is the handler that deals with it. We say is, this widget state has changed, so here are all the objects or the observer, as opposed to handler, that is the usual term, that who are interested or potentially interested in it. It's not really, we'll show that in more general. Having a single callback or multiple callbacks is actually not that drastically different because if you did manage somehow to force every event to correspond to a single callback ever, possibly, you would have managed to build a taxonomy of events. You know what? Suppose the mouse object has an event, it moved, and the widget object has an event, the mouse entered. You know what? One and the other will often both happen at the same time because the way the mouse pointer entered is because the mouse moved. So you can't really constrain either the mouse has moved handler or just the mouse has entered handler to trigger. You really want to trigger both. That's a very specific example of the fallacy of taxonomy. Taxonomy is never correct. Taxonomy is predicated on the underlying concept that something is either A or B. Well, I know things that are 72% A and 45% B. The overlap is deliberate. It totally isn't 100%. Taxonomy is a great temptation for the human mind, but it's hardly ever right. Anyway, in particular, it's hardly ever right when applied to all except the simplest callback situations. So anyway, an object must be aware that its state is changing, which is presumably has. For example, it will have mutating methods. It knows when a mutating method is called that changes the state. Other methods don't, and it somehow keeps track of all the observers it must inform when the state changes, and it simply does it. After or maybe before implementing the state change, every observer is notified. Why before? Why would you do that before? Well, because maybe you want to let observer veto the state change in a certain situation, in which case you do the calls before implementing the state change. If some observer vetoes the change, then you actually just quit the mutating method. Otherwise, you implement the change and then call the non-vetoing observers. You can have other design choices too. General observer would be one that gets informed of any state change and is totally responsible in a way that's entirely opaque, entirely inside the object, to know whether it's interested in that state change or not. and that's okay. It's obviously the most general possible approach, but often you may want to know only about objects of a certain kind. For example, I may want to do stuff when keys get pressed. Now, exactly what key may be too specific, but I don't really want to be called every time a mouse moves, because I just don't care. It's just sheer overhead, having to say, if the event is not a key press, then go away. It's maybe your framer lets you say only key presses are state changes of interest on the keyboard object. And you, again, may recur to, instead of having a simple callable, having a group of callables, meaning an object with several methods, so that they get called. For example, the observer object might have a method that gets called on key presses, one that gets called on mouse moves, and so on. So you don't have to explicitly code yourself. If it's key press, then something else. If it's mouse move, something else. Which one makes sense depends a lot on specifics of the framework that is organizing all this. I'm just pointing out all of the design issues. If you're ever designing, or if you're looking at an unfamiliar framework, consider that it may be doing things different than you're used to for possibly good reasons, possibly not, but this is what you have to deal with. Similarly, you can have several kind of callbacks in that a callback might have no argument at all. Or a reasonable idea, for example, for the observer design pattern is pass the target object whose state just changed. So you can use a single observer to deal in similar fashion with different possible observed objects. However, this does require, since no indication is given of, okay, what state changed how, to somehow explore. So having a description of the state changes will save all the, so is the mouse in the same place that it was before? Yes. Is the key being pressed the same as it was before? Yes, and so on, which can be rather cumbersome. The description of the event may, in particular, as it does in TK Inter, include, okay, oh, and by the way, on which widget has the event occurred? But first, what type of event? A mouse move, and then details like X and Y coordinates, object on which the mouse move. But then, this is all about the event. But the callable themselves may also require other arguments that aren't really connected to the specific event, but to the reason it's being put in charge of watching over that event. For that purpose, the general solution would be functools.partial, which binds some arguments, positional star A and named, the star KW, pre-binding them into a projected callable with partial application. This is a general thing, and if, okay, somebody will say, lambda is the most general thing. Again, if you avoid lambda, you will hardly ever have to complain about that. Having to, for example, set this callback with an explicit functional partial, why can't I just set the callback with directly giving what A's and key W's do I want to pre-bind? Why can't it do the pre-binding for me? The answer, it perfectly well can. And while I love single purpose tools, the difference in elegance between having the A and KW passed directly to set BK and having to wrap the functionals partial around is so huge that I really think this is a better design, and some, but not all, of the Python callback systems do that. If you ever find yourself designing a callback system, please look for the second form. Instead of just memorizing the callable, you memorize a callable, tuple A, and dictionary KW, and live happily ever after, and nobody needs to, yes?
You've been going on about sort of saying lambda considered constant.
Uh-huh.
Isn't lambda a higher level of abstraction than
Is lambda a higher level of abstraction as well as this? Not in Python. Lambda in Python does not allow you to have statements inside, and therefore is not a higher level of abstraction. It's a abomination. And Guido had wanted to originally to delete it from Python 3 because he just couldn't find a good way to allow statements in it, and that thing was never acceptable. He unfortunately then let himself be lobbied into keeping it around, and so everybody who gets my talk will continue to get bored by my explaining why lambda is just wrong in Python. You want Lisp, you know where to find it. This isn't it. Even though my good friend Peter Norvig keeps saying that, well, it's much the same, but it's not. Other questions? No. Okay. So now we come to the general issue that I described earlier for Observer. What if there's more than a callback set for a single event? Maybe because the event falls into two overlapping categories, or maybe more directly. The simplest and roughest way is to remember and call the last handler that was set. I remember doing that about 30 years ago, or dealing with that about 30 years ago with PC-DOS 1.0, which allowed only one way to handle an interrupt. So what you did, you saved the previous handler, then you set yours, and all the handlers were responsible for chaining the call until it got, well, it was pretty rough indeed, but for 30 years ago, I guess it was acceptable, simplified the kernel, if it deserves being called a kernel. Alternatively, well, we've got like more powerful tools now. Why not remember them all? Well, the problem is you still have to make some decision. Last in, first out, or is there like a priority order? It's far from obvious. Also far from obvious is, by the way, I set 5 callbacks to be called in some order. Now, how do I remove one of them? If the order is specified, can a callback that just happens to come in early say, okay, I'm all done, every other callback after me, don't even bother it, nothing to see, move along, move along. These are very difficult design choices because there is no single good answer. And whatever you pick, you will wish in certain other usage cases to have picked the other way around. All I'm saying here is trying to make you aware that these are issues. There is no obvious solution to them. Well, if you don't specify the order in which multiple callbacks occur, it then follows that no callback can preempt the others, because that would make absolutely no sense. You'd give a random callback and order. If you don't specify order, strongly recommend, like you can get now optionally depending on how you build your Python binary, do explicitly randomize them. Otherwise people will will end up relying, not having read your documentation that says the order isn't guaranteed, will happen to rely on whatever order happens to be. You can now compile Python so that it randomizes every time the order of keys in a dictionary instead of just not caring. I will predict that if you do a lot of unit tests, 20% of your tests will break because they just happened to rely without knowing it on a dictionary order. It's been happening to me. So anyway, if you're aware of all of these issues, you stand a chance of making these difficult decisions. If you're not even aware that there's a decision to be made, then your chances are much lower. So depending on this decision, there will be implementation. For example, if you decide the order doesn't matter, then you can use most anything like a set to hold all the callables. If you decide it's last in, first out, or first in, last out, you need to keep track of the order. The problem of how to remove a callable is actually particularly hard, but If you can have exactly the same callable object in a remove function, then whether it's a set or a list, you can still look for it. It will be much slower in a list if it's a very long list. But in practice, in my experience, you often want to have multiple callbacks. But by multiple, you mean 3, not 3 million. So even looking in a list isn't going to call you. So don't worry about the implementation to make these decisions. It's not what really matters most. And finally, I've already mentioned in the past, you have to decide in the case of multiple things whether you want separate callables for flexibility or to make sure the various things are consistent with each other, have them be method of a single object. Again, both choices can be right. I tend to think functionally more than I do object-orientedly, but that's just my instinct, and when I design APIs, I try to think about these things in depth because I know that once the API is published, changing it is going to be such a pain that I'll have to live with whatever decision I'm regretting for, not saying the rest of my life, but far too long. Are errors events like any other? Maybe, but I think there's a very good case to suggest they are best singled out. You may have a cascade of actual events, like still successes, and then a cascade of possible exceptions. And for that, I'm particularly glad to have Glyph in the audience because he's one of the guys responsible for this concept of deferred, which remains to this day a great way to organize. It's not the only way, but it is one simple, very linear, a cascade of of chain or cascade of success callbacks, a chain or cascade of error callback. Every one of them accepts star A and star KW, so you don't have to use functional partial, which is excellent little design convenience. And you get argument to identify what event, what error, and this is how the chain works. So it's not exactly a preemption. It's each event in the chain can modify and return and pass on to the next one the error or result of the previous one, the callback. So it is at least something you can lift without hardly any effort, even if you're not doing anything related to networking, like the system in which Twisted, in which deferred were originally conceived. It's still going to work for you. I believe this also has the distinction of being the only Python library concept copied verbatim in a popular JavaScript framework, Dojo. Dojo others are in general obvious admirers of Python, but this one is like they really moved, just transliterated from Python to JavaScript.
You can also use deferred standalone now. There's a standalone library.
Yep, I don't know if this old paper points to it. You probably just need to use a web search engine. Does anybody know any web search engine? Or maybe you can find Yelp reviews for it. I'm sorry, I can't hear you.
The first time I saw that in Twisted, I thought that was way too complicated. There must be a better way to do it. But you mentioned JavaScript copying that, and it's jQuery has an implementation of deferred promises A's and Node.js. Every JavaScript framework that deals with asynchronous code has directly stolen Twisted's implementation, which is good enough to make smart people can't find a better way.
So just for the recording, somebody was explaining that it's not just Dojo, there's just very similar things copied into all. Remember that asynchronous programming is very general, it's very applicable to JavaScript. Well, it's also one of the, passing function objects around is one of the very few corners in which JavaScript is better than Python syntactically, because the keyword for function is function instead of def, well, and lambda. But to do anything to do with the team known as the Spartans, it just function means function. It's the one bit where JavaScript got it right and Python got it wrong. So there are several kind of events that are intrinsic to the system, such as your running program or process, rather. So the attexit library lets you register a callback that will be called in normal shutdown, not if the Python binary interpreter crashes, but for both the normal and error exits within the Python control. Signal to let you handle unique signals. This one is one of those where you only have one handler per signal number, and when you call signal, it returns the old handler, so you can make believe it's still 1982 and have fun chaining the calls like you did in DOS 1.0. Isn't that fun? Or maybe you can program at a slightly higher abstraction level, but sometimes you really have to handle signals. And then there's a series of hooks that you can use. For example, sysaccept hook is going to be the callback whenever the interactive interpreter detects an exception. The default one just gives you a big stack trace, but you can actually do something very different. Set trace, set profile, display hook, there's all stuff that can be really helpful especially if you're like writing or hacking on Python IDE, because it's all stuff that's happening to your interactive execution. And some extension modules follow exactly the same, like readline lets you set all sort of system event callbacks. Then I did mention pseudo event to structure execution by making them up. Parsing is an example. The original approach to parsing stuff like XML was, well, let me process all the XML stuff and end up with a big document in memory. And that organizes a tree, a physical tree to correspond to the logical tree. That's the XML document. That's the DOM, document object model. Point is, okay, so XML took over the world, and now I have I regularly receive from my partner over there a JavaScript document about 100 gigabytes each. Uh-oh. Where can I buy a terabyte of memory to hold the DOM for that? It's pricey. I mean, you can buy it today, but it's pretty pricey. And actually, I only need to find where there's a tag foo within a tag bar, what's the attribute bus. That's all I care about all of these 64 gigabytes. Well, with the DOM, that doesn't matter. You have to have it all. So event-driven parsers like go over, they open tag this, close tag that as events. So you can simply ignore all the junk you don't care about, which in the average XML case is 97.2%, I think, about, approximately. And just capture and keep around those you need. Or you can use Paul Prescott's pull DOM concept, now available in several implementations, where you essentially start as a stream of events, but when you find one that, oh, I know I need this, you get the DOM-like structure for everything that's below this node. That's a DOMy subtree, as I call it. That's a pretty original approach to parsing, but it's partly event-driven. And the real motivation for the event-driven is to make it serial, so not everything has to stay in memory, considering that in those documents, you don't care about most of it. So you don't really want to buy a terabyte of memory just to handle it. For scheduled, I already mentioned sched in terms of the customization, but of course, as I mentioned earlier, what it does is it makes scheduled calls to your functions, so your events. With a certain delay, priority, this is the callable, the arguments, and so on. You can cancel the events, and when all the queue is ready, you run everything. And this is serialized, but then there's a concurrent version, which is the part of, like with thread, and to some, and of course, with processes and other concepts yet, like green threads and stacklets and so on, and other alternatives such as the NWS SLAY, which has elements and workers cooperating. This is where things start to get really hairy compared to the cleanliness of the asynchronous execution, and many alternatives such as the future, also known as promise design pattern, are getting into the standard library in Python 3. And a very interesting structure based on that is part of the NDB module for App Engine. That's fully available as source. Just get the App Engine SDK and or Git package and so on, and hack to your heart's content.